Hello again, 5th primary students, a new math lesson under the supervision of the Ministry of Education. أهلا بكم طلبة وطالبات الصف الخامس الابتدائي ودرس جديد أو تكملة للدرس السابق تحت رعاية وإشراف وزارة التربية والتعليم. Now we will discuss two more properties regarding the natural numbers. المرة اللي فاتت احنا اتكلمنا على properties بتاعت addition و subtraction, and as we learned they were opposite to each other, and all the properties were applicable أو بنقدر إن احنا نطبقها in the addition in natural numbers, بس ما كانش بينفع إن احنا نطبق the same properties in subtraction. دلوقتي احنا هناخد الحاجات دي أو هنحاول نطبقها on the multiplication. The multiplication, it goes a little bit like, or goes to a great deal like the addition in natural numbers. Okay, so let's see if we can apply the same properties or not. Multiplication in natural numbers, the first property is closure property. Here, natural numbers are always closed under multiplication. They are always closed under multiplication. It means that if I multiply two or more natural numbers, they will yield a natural number, or the answer will be a natural number. So A times B equals C, where C belongs to N. Yani, when I have two whole numbers or two natural numbers and I multiply them by each other, the answer will also be a whole number or a natural number. ولا هيبقى negative number, ولا هيبقى decimal number, ولا هيبقى fraction. Let's apply it on numbers. 1 times 2 is 2, 3 times 4 is 12, and extra. So in these cases, the resulting number is a natural or a whole number. Now let's move to the second property, the commutative property. For commutative property, multiplication of natural numbers show the commutative property. يعني البروبرتي بتاعت الcommutative دي متحققة في multiplication. Takes place in multiplication. For example, if I have two natural numbers x and y, x times y equals y times x. يعني هنا ال equal sign acts as a mirror زي ال addition. Okay, then 7 times 2 is 14, and 2 times 7 is also 14. Then the equal sign here, it acts as a mirror. Okay. Associative property, the third property. For associative property, also under multiplication, it holds true. Okay. Then I can apply the associative property on multiplication as well. So if I have the three numbers a, b, and c, a times b, when I get the answer, I multiply it by c, it is equal to a times, between brackets, b and c as well, and they are both equal to a times b times c. But then here, they act as the equal sign here also act as a mirror, exactly the same concept that we have learned about in the addition. Okay, so 4 times 3 is 12, times 2 is 24, equals to 4 times 3 times 2 is 6, times 4 is 24, and 4 times 3 times 2 is also 24. Then the equal sign here acts as a mirror. Now let's move to letter D, multiplicative identity property. Do you remember the additive identity property? We said it was 0, or it is 0, because 0 is like the heir to the multiplication question. It changes nothing. Then in the multiplication, the multiplicative identity property is not 0, because anything that I multiply by 0 is 0. In this case, it is 1. 1 is my neutral element for multiplication, because any number that I multiply by 1 stays as it is. It does not change. So For example, A times 1 is the same as 1 times A. Again, my equal sign acts as a mirror. So here 7 times 1 is 7 and 1 times 7 is also 7. Both of them are equal. Multiplication by 0. Pay attention. Here we have discussed the 4 properties that we learned about in the addition in natural numbers. But we have 2 more properties in case of multiplication. Then in addition and subtraction, we discussed 4 properties. In the addition, they were applicable, بيتحققوا, while in the subtraction, they are not applicable, ما ينفعش أحققهم. In the multiplication, أنا عندي المرة دي مش 4, أنا عندي 6 properties بيتحققوا في multiplication in natural numbers. The new 2 properties are multiplication by 0. For any A belong to n, A times 0 equals 0 times A. إنه أي number I multiply by 0 is a 0. So it doesn't matter if I put the 0 first or last. Whenever I have a 0 or I multiply by a 0, the answer is a 0. The last one is distributive property. Distributive property يعني بوزع. طيب, what is the thing that I distribute and how I distribute it? Multiplication of natural numbers is always distributive over addition. This is true because as you see here, A times between brackets B plus C, it is the same as yes, it's the same as A times B alone plus A times C alone. إزاي in numbers? If I have an example as the one in front of you now, here 2 times between brackets 3 plus 4. لو حسبناها هنلاقي 3 plus 4 is 7 and 7 times 2 is 14. طيب, لو وزعنا ال 2 دي or we multiply it by every element inside the brackets on its own. خدنا كل element لوحده عملنا له multiplication by 2 وبعد كده خدنا ال answers عملنا لهم plus. 2 times 3 plus 2 times 4. 2 times 3 is 6 and 2 times 4 is 8. When you add the 6 to the 8, the answer is 14. يبقى then here multiplication of natural numbers is also distributive over is distributive in natural numbers. And this also can happen with subtraction. This also can happen with subtraction. يعني إيه؟ يعني لو كان B minus C مش B plus C between brackets, I can also distribute the numbers on each other. So here, for example, A times between brackets B minus C. المرة دي مش B plus C. Again, I can do the same. A times B minus A times C. So here, 2 times 5 minus 3. 5 minus 3 is 2. 2 times 2 is 4. Equals 2 times 5 is 10. And 2 times 3 is 6. 10 minus 6 is also 4. Then distributive property can be applied in multiplication over addition and subtraction. Now let's practice. 4 times what equals 6 times what? طبعا احنا شايفين هنا ال equal signs دول ال mirrors بتوعنا. وas we said إنه كل ال properties are applicable عند ال multiplication. يبقى اللي أنا هعمله إني هشوف إيه الرقم اللي مش موجود في أول part وموجود في تاني part اللي هو ال 6. Then I will write it in the empty place. طيب دلوقتي إيه الرقم اللي موجود في السكند part مش موجود في الفيرست one ال 6. يبقى أنا I'll choose اللي مش موجود which is the 4. طيب الانسر بقى final answer 6 times 4 is 24. Okay. عشان كده بنقول إنه شوية زيها زي الأديشن. 8 times what equals what times 8 equals what. طيب إيه النيوترال element بتاعي في المالتيبليكيشنز اللي يخلي في المالتيبليكيشن اللي يخليها زي ما هي؟ It can be the 1, it's my neutral element, or in this case I can also use any number that I want. Okay? أي number هحطه هيبقى صح. 8 times 10 equals 10 times 8, 8 times 2 equals 2 times 8, whatever the number that I'm going to put is accepted. So here 8 times 5 equals 5 times 8 equals 40. أو I can go على طول لماي neutral element اللي هو ال 1. 8 times 1 equals 1 times 8 equals 8. Okay? Here. 7 times what equals 1 times what. Again أنا عندي قلنا ال equal signs دول مرايات. Then the numbers between every two equal signs is identical, or they are identical. So here 7 times what equals 1 times what. اللي مش موجود في الجزء الأولاني ال 1 I'll put it. اللي مش موجود في الجزء الثاني ال 7 I put it. Then the final answer 1 times 7 is 7. Letter D, associative property. 6 times 3 is 18 times 5 whatever equals 6 times I have two spaces. طيب هبدأ أشوف إيه اللي موجود عندي وأكنسله. 6 موجودة هنا وموجودة هنا، يبقى ال 2 empty spaces اللي موجودين between brackets هحط فيهم ال 2 numbers الموجودين قبل ال equal sign بس مش موجودين عندي بعد ال equal sign عشان يبقوا الاتنين مراية لبعض. So it will be 3 and 5. Letter E, commutative property. تاني ال equal sign is my mirror. I have two numbers before the equal sign multiply each other, then I have to have the same two numbers after the equal sign. So here I have 238 يبقى اللي ناقص في ال empty space ال 65. Letter F, 13 times 5 times what? Again associative property equals 13 times 5 times 8. ال 13 موجودة on both sides, ال 5 موجودة on both sides، يبقى الرقم اللي مش موجود عندي ال 8. Then in the empty space I will put an 8. Letter G, what times 94 equals 94 times 1 equals what? Again ال equal signs دول الميررز بتوعي. 94 موجودة on both sides، يبقى الرقم اللي مش موجود ال 1 I will put it in the empty space and then I will multiply the 94 by the 1 and my answer will be 94. Now use the number line to find the following products. I have 1 times 5 and I want to know how to get it on the number line. So here my number line starts with 0 and I want to multiply the 1 by 5. It means that I will count the 1 5 times لأنه المultiplication احنا عارفين إنه هو repetitive addition. So it's 1 2 3 4 and 5. I counted 1 5 times. Now let's move to another example. 2 times 5. Again on the number line. Here I count the 2 also 5 times. So it's from 0 to 2. This is 1, 4. It's like jumping into or skipping numbers by 2. So it's 2, 4, 6, 8, and 10. So if you count here, I jumped in 2 5 times. Now the division in n. It's almost the same as the subtraction. It refuses a lot of the properties or almost all the properties, okay? So here Division, we know that it is the inverse operation of multiplication. العكس بتاعت multiplication. I mean إنه 12 divided 3 equals 4 عشان 3 times 4 equals 12. Okay? When I say 12 divided 3 is what? بفكر على طول طب هو 3 times what can give me 12. Okay? That's why it's the inverse operation of the multiplication. So let's start to talk about our properties. First, the closure property. In case of the division, natural numbers do not obey closure properties, which means that dividing two natural numbers might not give a natural number as a result. So 10 divided 5 equals 2. Okay, جميل, belongs to n. ليه؟ عشان هنا 2 times 5 is 10. It means that 10 is in table 5 and it is the bigger number on top. So it gave us a natural number. 10 divided 3, the answer is 3.33 or 333 or whatever, it's infinite. So it does not belong to n because the answer is a decimal number. In this case, the resultant may be or may not be a natural number. So let's move to commutative property. For commutative property, division of natural numbers do not show commutative property. Can we see an example? Yes, of course. For any natural numbers x and y, x divided y is not equal to y divided x. How? 8 divided 4 is 2. While 2 divided 8, it will give me a decimal number that is total, sorry, 8 divided 2 is 4. While 2 divided 8 will give me a decimal number which is totally different than the 4. Then they are not equal to each other. Now, the associative property. For associative property, it's also not applicable in division. For example, if I have the three numbers a, b, and c, a divided b divided c not equal to a divided b, then divided c. Example, 2 divided 6 divided 3 is 1 because 6 divided 3 is 2 and 2 divided 2 is 1. It's not equal to 2 divided 3 divided 6 because the other one, the answer will be 0.1 and so on. So it's not equal. Existence of neutral element. Does it apply on the division? Division operations of n has no neutral element. It has no neutral element. Dividing a neutral number except 0 by 0 has no meaning. I mean, if I have 0 over 3 equals 0 because 0 times 3 equals 0. While if I do the opposite, I mean if 3 over 0, or I have 3 over 0, this has no meaning. It is undefined. Now let's move to the last property, distributive property. Do you remember in multiplication when we talked about the distributive property and I multiplied the number outside the bracket by each number inside the bracket and then add or subtract them? This part, it's not also applicable on the division. Okay, so division operations do not distribute over addition and subtraction. Here is an example. A divided b plus c is not equal to a divided b plus a divided c. How? Here, 30 divided 2 plus 3. 2 plus 3 is 5. 30 divided 5 is 6. Now let's distribute it and see if we get the same answer or not. Here, 30 divided 2 is 15, plus 30 divided 3 is 10. 15 plus 10 is 25. Then the two answers are totally different. Then distributive property is not applicable, or we don't have any distributive property in division. So now let's recap all the properties that we have on the 4 operations in natural numbers. Let's go to the board and see how they look. So here is a table that recap or get all the ideas that we have studied today and the last session. The properties and operations on natural numbers. Here we have the names of the operations: addition, subtraction, multiplication, and division. And we see if it applies to, or the property is applied to every operation or not. So the closure property, commutative property, associative property, and neutral element. In addition, we have the 4 properties. They are applicable. And here in the subtraction, the 4 are not applicable. In multiplication, the 4 properties, they are applicable, and we add to them multiplying by 0 and distributive property. Division, none of these properties apply to the division, and this includes also having a division identity or distributive property. They are not applicable as well. We'll take some examples here. The first one, 1 divided by 8. 1 divided by 8, it will yield a decimal number, so it is not or does not belong to n. While here, B, 4 divided by 0, remember, it has no meaning. It is undefined, so it also does not belong to n. Now, let's move to this one. 0 divided any number is equal to 0, so it belongs to n. Letter D, 102 over 3 times 34 is also 102, so 102 divided 102 is 1, so 1 belongs to n. Now, 100 divided 100 is also 1, so it belongs to n as well. Letter F, 88 divided 11 is 8, so it's a whole number, so it belongs to n. Now 17 divided by 5, it's not in table 5, so I will get a decimal number, so it does not belong to n. And the last one here, 3 plus 7 is 10, 10 divided 20 is half, so it does not belong also to n. So that's it for operations in natural numbers. We'll start now talking about patterns. So our lesson now is the numerical patterns, okay? What is a numerical pattern? Numerical patterns are arrangements of numbers according to certain rules called pattern rule. The rule that I move with is called a pattern rule. Example, as you see in front of you here, I have the numbers 11, 17, 23, 29, 35, 41, 47, and 53. If you notice here, we jump every time. We jump forward by 6. I add 6 every time. Between every number and the other one, I add 6. So my pattern rule here is to count forward by 6. We practice 5, 7, 9, 11. We started with 5, and to get to the successive number, our number اللي بعده, we added 2 and so on. نركز من أول number. 5 and 7. إيه relation بينهم؟ إنه I jumped by 2 or I skipped counting by 2. And from 7 to 9, I also skip counting by 2. Then this is my pattern rule, adding 2 every time. Then after 11, I have 13 and I have 15. Now let's take more examples on patterns. Okay, dear friends, now we'll take some more examples on patterns. So, for example, if I have a pattern like this one, then I continue this way. So, the pattern I move with is adding a row, and every row that I add one more dot to it. So, the answer will be, if I have one space here, my answer will be 1, 2, 3, and 4 dots. So, this is how my pattern will look like. Now, let's move to another example where we move backward and not forward. So for example, if I have here 30 and then 25, and I want you to get me 2 more answers. So as you see here, I move backward, I get smaller by 5. Then 25 minus 5 is 20, and 20 minus 5 is 15. So my pattern rule here is subtracting by 5 every time. Okay, now our last example. If I have here 2 and 5, then I add 10 to each one of them every time. Then it will be 12 and 15. Then I add more 10, so it will be 22 and 25. So this is the pattern that I follow, is adding 10 every time. So that's it for these examples. And our last example for today, as you see in front of you, we move with a certain pattern: 1 times 1, 2 times 2, 3 times 3. So the pattern here is to multiply every 2 similar numbers by each other, but we move in order, one by one. So the answer will be 4 times 4 and 5 times 5. Because as we said here, we started by multiplying 1 by 1. Then to get to the successive number, we elevate it to another number, which is 2 times 2, and so on. So my pattern rule in this question is multiplying every 2 similar digits and growing in order. That's all for today. I was glad to be with you. Study well and see you next time.